The most important company in artificial intelligence was not founded to build artificial intelligence. In 1993, NVIDIA was trying to make video games look better, competing against more than 20 graphics chip companies in one of the most unforgiving markets in technology. By 1996, there were around 70 companies in that race. 10 years later, NVIDIA was the only independent company from that original group still operating, but survival was only the beginning because somewhere along the way, NVIDIA made a decision that seemed almost unrelated to its original business. Today, NVIDIA sits at the center of the AI revolution, supplying the computing infrastructure behind some of the world's most advanced systems. But when the decision that made this possible was taken, the AI industry that would eventually depend on it did not exist. There was no ChatGPT, no generative AI, and no trillion-dollar race for data center capacity. NVIDIA was simply trying to solve a graphics problem, and that is what makes the story so difficult to see in hindsight. So how did a company built for video games become one of the most important pieces of the AI economy? To understand that, we have to go back to the problem NVIDIA was originally trying to solve. In the early 1990s, personal computers were becoming more powerful, while video games were becoming dramatically more ambitious, but creating realistic 3D graphics required enormous amounts of computation. That created a gold rush in the semiconductor industry. Companies rushed to develop graphics processors that could render increasingly complex worlds in real time, and NVIDIA entered that battlefield in 1993, founded by Jensen Huang, Chris Malachowski, and Curtis Priam. NVIDIA had no dominant position and no guarantee of survival. In a market where a new architecture could make an older one obsolete almost overnight, a single failed product could threaten an entire company, which meant NVIDIA's first objective was not to transform computing or build an AI empire. It was simply to survive long enough to build the next generation of graphics technology. That pressure shaped the company's early strategy, and in 1999, NVIDIA introduced the GeForce 256, establishing what it called the first GPU. Its importance went beyond better graphics because the architecture was designed around massive parallel processing, allowing enormous numbers of calculations to happen simultaneously. For video games, that was a major breakthrough, but hidden inside the architecture was a much more interesting possibility. If a GPU could perform thousands of calculations at the same time, why should those calculations only be used to render pixels? That question would eventually become more important than any game NVIDIA had ever rendered. The problem was that the hardware had been designed around graphics, so unlocking its potential for completely different problems would require something NVIDIA could not simply manufacture in a factory. It needed software. In 2006, NVIDIA introduced CUDA, opening the parallel processing capabilities of its GPUs to general-purpose computing. Developers and researchers could now use the same basic hardware for scientific simulations, engineering, data processing, and other workloads far beyond graphics. But there was something unusual about the decision. NVIDIA was investing in this capability before there was a massive market waiting for it, which meant the company was spending resources on a future it could not clearly describe. The AI revolution had not arrived yet. ChatGPT did not exist, generative AI was not a mainstream industry, and nobody could know that enormous data centers would eventually depend on the very architecture NVIDIA was expanding beyond graphics. That made CUDA a genuine strategic bet. NVIDIA was not responding to a demand that already existed. It was trying to make its technology useful for problems that might become important later. And for years, there was no guarantee that this bet would pay off. NVIDIA still had to compete in graphics, while the broader computing industry remained dominated by conventional processors and established software ecosystems. Then, in 2012, NVIDIA received a clue that changed the meaning of everything it had been building. At the University of Toronto, researchers developed AlexNet, a deep neural network that produced a breakthrough result in the ImageNet image recognition competition. The critical detail was that the network was trained using NVIDIA GPUs. The important part was not simply that AlexNet won, it was that the same processors originally designed to make video games faster were now helping machines learn from enormous amounts of data, revealing that GPU parallelism could be extraordinarily useful for a completely different kind of problem. Suddenly, CUDA looked less like an expensive experiment and more like preparation for a new era of computing. NVIDIA had not built the system specifically for AlexNet, and it certainly had not built it specifically for ChatGPT. but it had created a platform researchers could use when machine learning began demanding enormous amounts of computation. The company had not predicted the exact application, it had prepared the platform. And that distinction would become the foundation of NVIDIA's advantage. The company was no longer competing only on the performance of an individual chip. It was building an ecosystem around that chip, including software libraries, developer tools, optimization technologies, networking, and complete computing systems. A rival could design a powerful processor. The harder question was whether that rival could convince developers to abandon years of software, rebuild their workflows, retrain their teams, and move away from an ecosystem that was already becoming deeply embedded in computing. That created a powerful feedback loop. More developers built for NVIDIA, making the hardware more useful. More useful hardware attracted more customers, which justified more investment, and more investment strengthened the platform even further. The GPU was no longer simply a product. It was becoming an ecosystem, and ecosystems behave differently from products because they accumulate software, developers, knowledge, and infrastructure over time. A product can be replaced when something better arrives. Replacing an ecosystem means replacing everything built around it, and NVIDIA had spent years creating those connections before the biggest opportunity had even arrived. But there was still one question nobody could answer. Would artificial intelligence become important enough to transform the economics of computing? The answer emerged gradually as deep learning advanced. Neural networks became larger, training datasets expanded, and the computational demands of machine learning began increasing at a pace that made massive parallel processing increasingly valuable. GPUs happened to be exceptionally well suited to that problem. What had once been technology designed to render increasingly realistic game worlds was becoming a tool for training machines to recognize images, process data, and eventually generate entirely new forms of content. Then AI crossed another boundary. It stopped being something most people encountered mainly in research papers and became something ordinary people could use. When ChatGPT launched in late 2022, millions of people suddenly experienced large-scale AI directly, but behind that interface was a much less visible reality. Every answer required enormous amounts of computation. The AI revolution was becoming an infrastructure revolution, and NVIDIA was already standing inside that infrastructure. This is where the company's financial transformation becomes almost difficult to comprehend. In fiscal 2026, NVIDIA reported $215.9 billion in revenue, with $193.7 billion coming from data center. The comparison is more revealing than the raw number. A company that began by trying to improve computer graphics was now generating almost 90% of its annual revenue from data center, while gaming generated $16 billion. Gaming had not disappeared, it had simply stopped being the center of NVIDIA's economic identity. NVIDIA had not merely become a larger version of the company it was in 1993. It had fundamentally changed what kind of company it was, moving from graphics technology toward accelerated computing and AI infrastructure. And that reveals something important about what NVIDIA actually sells today. It is tempting to think of the company as a manufacturer of powerful GPUs, but the GPU is only one part of a much larger platform that includes software, libraries, networking, systems, and developer tools. Together, those pieces form an ecosystem designed around accelerated computing. That ecosystem is now deeply embedded in the infrastructure companies use to train and operate modern AI systems. This is why NVIDIA's advantage became so difficult to measure by looking at the chip alone. The chip matters, but so does everything that makes the chip useful, and every year of software development and developer adoption makes the surrounding ecosystem more valuable. But every advantage creates a new problem. The stronger NVIDIA's position becomes, the more complicated the system around it becomes. Advanced semiconductor manufacturing requires specialized fabrication and packaging, while AI infrastructure requires memory, networking, data centers, enormous amounts of electricity, and customers willing to invest billions of dollars. NVIDIA sits near the center of that system, but it does not control every part of it. That creates a new strategic question for a company that once only needed to convince gamers to buy better graphics. Can NVIDIA keep supplying a world that suddenly wants almost unlimited computing power? That is a very different challenge from the one the company faced in 1993. Back then, NVIDIA was fighting to survive in a crowded graphics market. Today, the world is asking it to supply the infrastructure required to build an entirely new generation of computing. and the competition is changing with it. Other semiconductor companies want a larger share of the AI market. Cloud providers are developing their own accelerators. Customers want alternatives. Governments are paying closer attention to advanced computing and semiconductor supply chains, and the technology itself continues to evolve. NVIDIA's position is powerful, but powerful positions are never permanent, which brings us back to the decision that started this entire story. CUDA. In 2006, Jensen Huang could not have known that generative AI would become a global phenomenon. He could not have known that language models would eventually consume enormous amounts of computing power, or that companies would spend billions of dollars building data centers around accelerated computing. What he could see was something much smaller. GPUs were exceptionally good at parallel computation, and NVIDIA had a choice: continue treating them primarily as graphics processors, or build the software that could turn them into a broader computing platform. NVIDIA chose the second option. That decision did not tell the company exactly where it would end up. Instead, it expanded the number of possible futures in which NVIDIA could win. And that distinction is what makes the story so important. If NVIDIA had remained focused only on gaming, the AI boom might have created an opportunity for someone else. But when researchers needed massive parallel computing, NVIDIA already had the hardware. When developers needed software, NVIDIA had CUDA. And when companies needed complete systems, NVIDIA had spent years building the ecosystem around them. The opportunity arrived. The infrastructure was already waiting. That is why NVIDIA's story is easy to misunderstand. From the outside, it looks like an AI company that suddenly became enormous because artificial intelligence exploded, but from the inside, the sequence looks almost completely different. The AI explosion did not create NVIDIA's advantage. It revealed the value of an advantage that had been built years earlier through decisions whose importance was impossible to fully understand when they were made. Graphics became GPUs. GPUs became programmable computing platforms. Those platforms became essential tools for machine learning. Machine learning became deep learning, and deep learning became a foundation for modern AI. Looking backward, the sequence feels inevitable. It wasn't. CUDA could have failed. Developers could have ignored it. Another architecture could have become dominant. Deep learning could have evolved differently, and the AI boom could have rewarded a completely different company. The future only looks obvious after it arrives, and that is what makes NVIDIA's story more interesting than a story about a company getting rich from artificial intelligence. The real story is about positioning. NVIDIA did not know exactly what the future would look like. Instead, it kept expanding what its technology could do, creating capabilities that were useful beyond the boundaries of its original business. That gave the company something more valuable than a prediction. It gave the company optionality. When the world eventually moved toward a future that depended on massive parallel computing, NVIDIA was already prepared. It did not predict ChatGPT, and it did not invent the AI revolution. It had simply spent years building the capabilities that the revolution would eventually need. And that is the hidden ledger behind NVIDIA. The company's greatest achievement was not building the machine behind AI. It was building the capabilities before anyone knew how important AI would become. Sometimes the companies that appear to have predicted the future did something more difficult. They built for possibilities before the rest of the world could see which possibility would matter. NVIDIA did not know what the future would need. It simply made sure that, when the future arrived, it would be ready.